This video demonstrates the proposed gripper for fruit picking. Picking fruit with the gripper involves three steps: contact detection, ripeness estimation, and fruit picking. The gripper is operated in the sense mode for the first two steps due to its high force sensitivity while avoiding fruit damage. For the final step of fruit picking, the gripper is operated in grip mode to ensure a firm grasp during plucking. For contact detection, the gripper is operated in the sense mode and its finger is moved until contact is detected with the fruit, which occurs when the feedback motor torque crosses a pre-calibrated threshold torque. In this mode, the gripper applies only about 23 grams of force on the cherry fruit as estimated from the motor torques. The size of the cherry fruit is estimated to be 2.3 centimeters from the motor position feedback. As the next step, we estimate the stiffness of the fruit, which will be used to estimate its ripeness. Once contact is detected, the motor torque is increased linearly and the stiffness in actuator space is estimated from feedback motor position. This stiffness is multiplied by the Jacobian of the finger mechanism to obtain an estimate for the fruit stiffness. The stiffness and size estimates are used to classify the fruit as ripe or damaged. The boundary for classification is predetermined using k-means clustering on data obtained previously from ripe and damaged cherries. Since the cherry is classified as ripe in this experiment, the gripper switches to grip mode to grasp and pluck the cherry out of the stem.